Okay, let's look at section 8.6 continued, right? So one thing we need to check is that when we define addition and the multiplication on Z mod n, we have to make sure that definition is well defined, right? Why is that even a question? Right, here's the question deal. When you use the equivalence class, you could use different representatives for the same equivalence classes. But when you define addition based on representatives, for example, representative for here is A, and another representative here is B. So when you do addition, A plus B is the new representative, but for the same equivalence classes, we might have different representatives. Of course, these are different numbers. When you add them together, they're going to be a different sums. But we need to make sure that the resulting equivalence classes are actually the same, right? So here's an example, right? So let's do a small example down here, right? So for example, in something small, Z mod 5, right? When you think of adding, say, equivalence class represented by 3 and equivalence class represented by 4, right? So that will be 3 plus 4 is 7, right? Right, but the 7 is 5 plus 2, so it's going to be equivalent to 2, right? But the 3 equivalence class represented by 3 is the same equivalence class as equivalence class represented by 8, right? And the 4 is same as, say, 14, right? When you add them, you're going to get an equivalence class, so 8 plus 14 would be 22. So equivalence class represented by 22, right? But we're not so sure that if equivalence class represented by 22 is the same as equivalence class represented by 7. But as it turned out, so 22 is 5 times 4 plus 2, so it's actually 2, right? So you get exactly the same thing, right? But we're going to prove this in general, all right? So let's do that. So first one. All right, so we assume that A equivalence class represented by A is equal to equivalence class represented by C, and equivalence class represented by B is same as equivalence class represented by D. All right, so this means that the two. All right, so this means that the A must be congruent to C mod n. All right, and this means that B is congruent to D mod n. Right, so this is given. Oops. So this is given. Right, so this comes from line 1, right? Then 3, right? So there must be, so A minus B is divisible by, A minus C is divisible by n, and B minus D is divisible by n. So therefore, there must be some integer. I'm going to use K and L, right, such that A minus C is equal to n times K, and B minus D is equal to n times L, right? Then we want to talk about a plus b and c minus d. So it's 4, right? So we have to think about consider a plus b minus c minus d, c plus d, right? Right, but this is the same thing as group A and minus C together. So this is A minus C plus B minus D. All right, which is, all right, A minus C is N times K. Right, B minus D is N times L, which so you can factor out N. So N times quantity K plus L. Right? Since K plus L is an integer, so this guy is a multiple of N, which means that the 5, right? Which means that quantity A plus B is congruent to um, C plus D mod N, right? If the representatives are congruent, therefore 6, right? So you have equivalence classes are the same, right? Right. This will show that the addition in Z mod n is well defined because there's no inconsistency because it doesn't depend on the choice of representative for the same equivalence class. Right? That's it. I hope that this was clear.